Hello boys and girls, this is Mr. M with our first voice thread project that we're going to try together in class. We have a review in the beginning of this presentation, a review of our volume of prisms, cylinders, pyramids, and cones. Some of the problems you may have seen before, some of them may be new. The second portion of this presentation will have some problems for you to try, and that's the point where you'll use your voice threading tools as we discussed in class. And there's a third part of the presentation which I call the more challenging problems, and at that point you'll be able to show your stuff, see if you can solve them, or at the very least be able to come up with the plan, which is half the battle for solving those problems. As you know, when we're exploring volume, the volume of a solid is defined as the number of cubic units contained in its interior, and volume is measured in cubic units. One of our first pictures that we discussed was actually physically filling up a rectangular prism such as this. Here we have a rectangular prism that takes 5 cubic units to fill its length, 3 cubic units back, and then 4 cubic units high. We could physically count the blocks here, or we could simply multiply 5 times 3 times 4 for a volume of 60 cubic units. We basically took the formula for the prisms, all the right-angled prisms, including the cylinders, and we broke it down and boiled it down to its essence, where volume is the area of the base times the height. In the case of the cylinder's base is made of a circle, so instead of saying area of base, we specify pi r squared. In the case of a triangle, you would have to do half the base times the height of the triangle, and so on. So we're really not trying to confuse you by saying each one is a different formula. We're going to stick with volume as area of base times height, and then just refer to your area reference chart depending on what the base is actually made out of. Here we have an example of a triangular based prism, and in this particular prism we have a triangle with measurements 3 by 4, and those are the two measurements we're going to use for our base and height of this triangle. How do we know? Because that's where the right angle is. So the first step is to find the area of the base, so that's 1/2 of 3 times 4, which is 6 square centimeters, and then we take that 6 and substitute it right here into our volume formula. So there's your area of the base times a height of 2 right here to give us a volume of 12 cubic centimeters. Here we have a cylinder, so we got to think our base is a circle, hence we're using pi r squared. Radius is 8, so 8 squared becomes 64 for an area of 64 pi. That 64 pi gets substituted into our volume formula times the height of 6. 64 times 6 is 384, and we're looking at a volume of 384 pi cubic inches. And if we needed the decimal approximation, we would simply use 3.14 in place of the pi. So the decimal approximation would be 1206.37. Cubes have to be the easiest of all for us. 10 by 10, it's a square bottom. So 10 by 10 is 100 times 10 high. Now we're looking at 1,000 square feet in this particular one. Obviously multiplying by tens makes life very simple for us. But what happens when our three-dimensional object comes to a point? Well, as we discussed in class, we did our liquid experiment, and we saw that it took 3 of the pointed objects to fill its neighboring right-angled prism. So the cone being the pointed version of the cylinder, and these pyramids being the pointed version of the right-angled prisms. It took 3 of these pointed objects to fill its counterpart. So we're going to use the formula 1/3 area of base times height. So essentially it's just one extra step that we have to take 1/3 of our answer. Alright, so here we have a square-based pyramid. So we're going to do the formula is volume is 1/3 area of the base times the height. In the case of the cone, the base is a circle, so when you think 1/3 area of base times height, you just have to substitute in pi r squared for its base. All right, here's a sample question done for us, so let's take a look at it. Here we have a cone with a radius of 12.4 millimeters. So we take the area of the base right there, pi r squared, and we substitute in the 12.4 squared. We have to multiply by the height of the cone, and then don't forget to take a third. So here we have 907.18. Don't forget that's a circle bottom, so it has a pi, so the decimal approximation would be about 2,850 cubic millimeters. Same procedure for a triangular based pyramid. So we have our triangle here. The base of our triangle is 4 and the height of our triangle is 7. So we got to get the area of that base, and there's your triangle area formula right there. 1/2 of 4 times 7, which gives us 14. Substitute that into our volume. Because it comes to a point we're taking 1/3 of the area of the base times the height. So we're looking at 28 cubic centimeters. Here's a few problems for you to try. I want you to take a look at these first few problems and use your annotation pencil, as we discussed in class, to show the steps as you record. And then after that, there's going to be a section where you can see the more challenging questions. I want you to give it a try. Don't be intimidated by them. At the very least, come up with your plan, even if you find it too difficult to solve. And we'll discuss it in class. Okay, talk to you soon.
So, as seen on screen, you can see how much ice cream can a Friendly's waffle cone hold if it has a diameter of 6 and its height is 10 inches. So, in order to do this, you need to do height times base. So, in order to find the base, you would have to do radius squared times pi. And the radius is, the diameter is 6 inches, so half of 6 would be 3. 3 squared is 9. 9 times pi. We're going to keep it in terms of pi, so it's going to be just 9 pi. And the height is 10, so 9 times 10 equals 90. And since it comes to a point, we have to divide by 3. So 90 divided by 3 is 30 pi. So, question number 1 asks, how much ice cream can a Friendly's waffle cone hold if it has the diameter of 6 and its height is 10? So in order to find out the answer, we have to do base times height, and you could find out the base by finding the area, which is radius squared times pi, since it's a circle, and it doesn't say the radius, it says its diameter. So we know radius is half of the diameter, so we split that in half, and half of 6 is 3. So we do 3 times 3, and that equals 9. So now it's 9 times pi. And it's up to you if you want to do 9 times pi now or leave it to the end. I'm going to leave it to the end. So we're going to put height, and the height here, it states it's 10. So that is 10. So we do 9 times 10, and that equals 90. So now, since it comes to a point, we're going to divide it by 3. So 90 divided by 3 is 30 pi. And it's up to you if you want to do pi. In this case, I'm not going to. But this would be your answer. Proceed to start over the method, which is 1/3 times the base and the height. And then you have to do pi r squared. And then you have to 1/3 times 3 squared, and then you have to multiply, and you have to do it with pi, and then you have to multiply that by 10. Once you do that, you have to do 1/3 times 9, and 1/3 divided by 9, like, what's a third of 9, and then pi times 10. So, do 30, 1/3, a half of 9, third half of 9, third of 9 is 3, and then you have to do 3 times 10, which is 30, so then 30, pi, have to do equals about 94 squared, 94.2 squared inches squared.
To find the area of how much ice cream can a Friendly's waffle cone hold if it has a diameter of 6 inches and its height is 10 inches, the diameter is 6 inches, meaning the radius is 3, and then you have to do 3 times 3, which is 9 times pi. But to multiply by pi is optional, so you don't have to do that. It's 9 pi times 10, which is 90. And since it goes to a point, you have to divide it by 3, which is 30 And you have to bring down the pi, and that's the answer. Next one. How much salsa is missing from the jar? You have to do 10 minus 4, which equals 6. 5 times 5, which equals 25. 25 pi times 6 equals 150 centimeters cubed pi. What size rainwater tank would be needed to hold the runoff when 2 centimeters depth of rain falls on a shed roof 3,600 centimeters long and 1,200 centimeters wide? So you multiply 3,600 times 1,200 and get 8,640,000. And with that, you multiply by 2 and get the answer is 8.64. Totally got that. Cube. What is the volume of this tanker? The diameter is 2, which means the radius is 1. 1 times 1 is 1. Times pi. So it's 1 pi times 6, which is 6 pi.
Hi, the first question says, how much ice cream can a Friendly's waffle cone hold if it has a diameter of 6 inches and its height is 10 inches? Since it is a cone and the base is a circle, to find the volume you have to do 1/3 the base times the height. To find the base, you have to do pi times radius squared. The radius is 3, so and the height is 10. So you have to do 1/3 times 10. 10. 3 squared is 9. Times pi times 10 and 1/3. So 1/3 of 9 is 3, so you just do 3 times 10 is 30. Pi. And that gets you, if you want to find the approximate, it's 94.2 inches cubed.
So the question is, how much ice cream can a Friendly's waffle cone hold if its diameter is 6 inches and its height is 10 inches? What the question is telling me is that this part right here, the height is 10 inches and the whole diameter is 6 inches. To find the area, you have to do 1/3 base times height. And the base is radius squared. So the radius would be 3 because it's half of the diameter squared. and then and height, times pi. And then the height is 10. And 3 times 3 is 9. So that's 9 pi times 10 is 90 pi, and 1/3 of that would be 30 pi. And 30 pi is 94.2 inches cubed.
Number 1. How much ice cream can a Friendly's waffle cone hold if it has a diameter of 6 inches and its height is 10 inches? Just ice cream within cone, not on top. So you know diameter is the full thing from side to side, which is 6, and radius is half of that, which means it's 3. So base times height is how you get this. And we need to take 1/3, since we know this is a cone and it's missing the bottom part, or 1/3 of its whole area or volume. So base equals pi r, which we know is 3, squared, and the base, or the height, is 10, and we take 1/3 of that when we're done. So this equals 90 squared, or 90 pi, and we take 1/3 of that, which equals 30 pi, which is about 94.2.
All right, so boys and girls, for this question, it's asking us to find the volume of a Friendly's waffle cone. The cone has a diameter of 6 and a height of 10. So what we're going to do is we're going to go to our formula for the volume of a cone, which is 1/3 the area of the base times the height. The base, once again, is a circle, so we have to think in terms of pi r squared. If the diameter is 6, that means the radius is 3. So I'm looking at 3 squared times pi times a height of 10. And don't forget, we're going to take 1/3 of this answer because it does come to a point. So 3 squared is 9. 9 times 10 is 90 pi. And then 1/3 of that is 30 pi, and that is cubic inches.
Yes, Mr. M, I got it right.
Yes, Mr. M, I got this answer correct.
I got this question correct.
I got it right, but I did not leave it in terms of pi, but it is still correct.
I got this question correct.
No, Mr. M, I got it wrong because I forgot it came to a point and I didn't divide it by 3.
So for this question, we have to find out how much salsa is missing from the jar. So we're going to do base times height. The base is going to be 5 squared times pi, and the height will be 10 minus 4 equals 6, and that's how we find out this part. So that 6 times 5. But first, before we do that, we have to do 5 times itself because it's squared. So 5 times 5 equals 25. 25 times 6 equals 150 pi, and we're just going to keep it in likes of pi.
So the question is how much salsa is missing from the jar? And you have to start off by doing 10 minus 4, and then you have to, which equals 6 centimeters. 6, and this is the height. So now you have to do the base times the height, and then you have to do pi r squared, and then after that, then you have to do 5, which is right here, squared, and then pi 6, because you get the 6 from the height, and then you have to 5 squared is 25, so 25, and then you have to multiply that by pi. You have to multiply that by pi, and then multiply that by 6. So you have to do 25 and 6, and then you get 150, and then 150 pi equals about around 471 centimeters squared. 470 let's cut this out, equals about 471 centimeters squared.
Since it says how much salsa is missing from the jar, to find the whole volume, you have to do 10 minus 4, which is 6. So to find the volume, you have to do 5 squared times pi times 6, since 10 minus 4 is 6, and 5 squared is 25, times 6 times pi. 25 times 6 is 150. Then to put the pi, and that is 471 centimeters cubed, and that is the volume.
So the second question is asking how much salsa is missing from the jar. And in order to find that out, you have to subtract 4 from 10. So you have to subtract 4 from 10, which would be 6, which is how much, 6 centimeters, which is how much of empty space there is. And then you do base times height. The base is the base is 5 centimeters, so 5 to the second power times pi times 6, And 5 times 5 is 25 times pi times 6. So this would be 150 pi, which is 471 centimeters cubed.
Okay, with regards to the salsa jar here, the question's asking how much salsa is missing from the jar. So what we can do is we can approach it one of two different ways. We can look at the entire jar and then subtract the amount of salsa that we see here, or we could look at just the empty space. I think that would probably be closer cutting to the answer if we just looked at what the difference was here. If we have an overall height of 10 and the amount of salsa is 4, that leaves us a gap of 6 centimeters height of just empty air. So we're going to use that number as our height for this cylinder question. So okay, this guy's a right angled prism, so we're going to do area of base times the height. The base once again is a circle, so we have to think pi r squared. The radius is 5, so 5 squared times pi, and then a height of 6 for the empty space of salsa. Okay, so 5 squared is 25 times 6 times pi. We're looking at 150 pi, and once again that is cubic centimeters. If you need the approximation, you can always use 3.14 for pi.
Okay, Mr. M, I got the same answer.
Yes, Mr. M, I got this one right.
I did not get this answer correct, but now I understand how I have to do it.
I got this question correct.
How much salsa is missing from the jar? So to find how much salsa is missing here, we need to do 10 minus 4, which is 6. So base times height. And we know the radius is 5, so pi r squared would be 5 squared times 6, which would equal 150 pi. I got it right.
I got this question right.
Mr. M, I got it right. This is base times height. You always start with base times height if it's a 3D figure. So this is depth, which is height. And then it's 3,600 centimeters long and 1,200 centimeters wide. You have to find the volume. Base times height. This is a square. No, it's a rectangle. Oops. So therefore, you just multiply all this. Three 3,600 times 1,200 is 4. 3, 2 is 4 zeros. Times 2. And that's 6. That's centimeters cube.
Question number 3 asks what size rainwater tank would be needed to hold the runoff when 2 centimeters depth of rain falls on a shed roof, 3,600 centimeters long and 1,200 centimeters wide. So in order to find the answer, we have to do base times height. And in order to find the base, we have to multiply these two numbers because it's how long and wide. So the length here and the width there. So in order to find out those answers, we multiply 3,600 by 1,200, and that equals 4,320,000, and the height is 2, so we multiply that by 2, so times 2, and that equals 8,640, and excuse my handwriting, and that's a really big number, so it's going to be difficult for people to understand that. I'm just rewriting it so you can understand it a little better. So since it's a whole number, it's a big number, so it's difficult for people to understand it. So in order to put this in terms that most people understand, we have to divide it by 1,000, which is meters, in order to find out how many meters it is. And that divided by 1,000 is 8.64, and that's your final answer. Meters cubed. There.
So you're going to start off with base times the height, and the base is 3,600, and then you want to multiply that by 1,200, and then multiply that by 2, and once you multiply these numbers, it equals about 8.640,000 centimeters squared. And once you've got this answer, you wanna squared. And once you have done that, you wanna 1,000. $1,000,000 actually, and that equals about 8.64 centimeters squared.
You have to do base times height times height. To find the base, you have to do 3,600 times 1,200, and the height is 2, so you have to multiply these together, which gets you 8,640,000, which in meters is 8.64 meters cubed.
So question number 3 is asking what size rainwater tank would be needed to hold the runoff when 2 centimeters of rain falls on a shed roof, 3,600 centimeters long and 1,200 centimeters wide. So to find the area of this, we have to do base times height. The base is 3,600 times 1,200. And the height is 2. So 3,600 times 1,200 is 320,000 times 2, and which would be 8,640,000, and divide it by a million to find the answer in meters. And that would be 8.64 meters cubed.
Number 3. What size of rainwater tank would be needed to hold a runoff when 2 centimeters depth of rain falls on a shed roof 3,600 centimeters long and 1,200 centimeters wide? So first, we need to find base times height. And the base is 3,600 times 1,200. And we know the height is 2. So when you multiply all of these together, you get 8,600 or 8,640,000. And to find that in meters, you need to divide it by 1 million. Which equals 8.64.
Okay, with regards to the rainwater falling on the roof, we have to think in terms of a rectangular prism. So we're going to, once again, use area of base times height. The base area would be 3,600 by 1,200 and a depth of 2. So now we have to do the multiplication here. We can bring up our calculator to assist us. So 3,600 times 1,200 times 2. Very large number. We're looking at 8,640,000. All right, putting our commas in place. That's 8,640,000, and that's cubic centimeters.
Okay, Mr. M, I got the same answer as you.
Yes, Mr. M, I got this one right.
I'm not really sure if I got this answer correct. I would say that I did, and but what I did after was I rounded it. So I would say I got it correct, but then I don't know if I did not get it correct or I forgot half because I also rounded it.
My answer was correct, however I used it in terms of meters instead of centimeters.
I got this question correct.
I did not put my answer in terms of centimeters, but I still got it right.
Mr. M, I got it right. This is a cylinder. So you have to find the radius, which is pi, so that you have to find the circle area, pi r squared, base times height. You have to find the area of this circle, 2. Half of 2 is 1, so it's 1. So this is 1. Okay, then pi r squared. 3.1 squared is 1. 1 times pi. 3.14. That times 6. And 3.14 times 6 equals 18. It's about 6 pi, which is about 18.84. And that's meters cubed.
So for question number 4, it asked, what is the volume of this tanker? And here it says the diameter is 2. So in order to find out the answer, you would have to find the radius, and the radius is half of the diameter, which is 1. So in order to find the base, it's radius squared times pi. So in order to find out the base, 1 squared is 1 times pi. And in order to find the height, it's 6 here. So it's 1 times 6 times pi. So 1 times 6 is 6. So we're going to keep it like that, 6 pi.
To find the volume of this tanker, you have to start off with a method which is base times height, and you do pi r squared. You have to pi r squared. Then you have to do 1 squared and pi times 6. You have to start off first by doing 1 squared, which is 1, and then you have to do that by times that by 6, and that equals 6, and then 6 pi equals to about 18.84 centimeters squared.
For this one, you have to also do base times height. And to find the base, you have to do pi radius squared. Since the diameter is 2, the radius is 1, so pi 1 squared. 1 times 1 is 1, so it's pi times 1. And since the height is 6, you have to multiply it by 6. This is equal to 6 pi. 6 pi is equal to 18.84 meters cubed.
Question number 4 is asking what the volume of the tanker is. This one's fairly simple. It's just base times height. So the base would be pi r squared, and the radius is 1, because the diameter of the whole circle is 2, and half of that is just 1. So that would be 1 squared times pi times the height, which is 6. So that's 1 times pi times 6. 6 pi, because 1 times pi is just 1 pi, times 6, so it's 6 pi, equals 18.84 meters cubed.
So number 4, what is the volume of this tanker? So we know that we need to find base times height. And the base is pi r squared, so pi, and the radius, which is 1, because we know the diameter is 2, and half of that would be 1. So we know that it's pi r squared, which is pi 1 squared, times the height, which is 6. And if you multiply all that, it'll equal 6 squared, which is about 18.84 meters.
Okay, we have one more basic question here. The volume of the tanker, we identify it as a cylinder, so we're going to use our formula of area of base times the height. Once again, the base is a circle, so we're thinking pi r squared. Radius would be 1 since the diameter is 2, so 1 squared is 1 pi, and a height of 6, so we're looking at 6 pi, and that would be cubic meters for this one. This was actually one of the more basic ones that we've had so far.
Okay, Mr. M, I got the same answer as you two.
Mr. M, I got this one right too.
I got this answer correct, and I really understand how to do this. It was actually really easy, so I got it correct.
My answer is correct, except for I used it in decimal instead of in pi.
I got this question correct.
I got this question correct.
Mr. M, I got it right.
Hi, Jordan, Natalie, Maliha, Emmanuel, Tamara, Vidrick, and Maurizio. This is Mrs. Trincali. I watched your math video with your voice threads, and I am just so proud of all of you. You did such a great job. I love the way you talked your problems out, and that not everyone did it the same way. So you really got to see and hear how other people think, which is very, very important. I enjoyed watching it. I think it was a great challenge, and you more than met it. Keep up the good work, and know that I'm very, very proud of you. Goodbye.
This is a base times height problem, but there's something you have to remove in the middle. It's a rectangular prism. So you have to find the entire thing first, the entire triangle. To find a triangle, it's base times height. So that's 6 times 4, and half of that. 6 times 4 is 24, divided by 2. That makes it 12. Excuse me. And then, then you have to multiply it by 5 since it's base times height. And this is the height. 5 is the height because it's on its side. So 12 times 5 equals 60. And then you have to find the square. So these are all even since it's a square. That's 2. That means 2 times 2, and the height is 5. That's 4 times 5, 20. So 60 minus 20 is 40,
feet cubed. This probably is a bit more challenging because this is a bit more complex. So you have to start off with the volume of the triangular prism, and you're going to do that by doing base times height, and then do 1/2 of the base times the height. You have to do 1/2 times base times height, and then 1/2. The base is 6, and the height is 4. So then 6 times 4 is 24, and then divide that by half, which is 12. 12 times 5, which equals 60 feet. 60, and then to find the volume of this little rectangular prism, you have to do base times height. So, and then the base is 2, the height is 2, and then you have to multiply that by 5. The base is 2, and the size is the same, so it's 2 times 2, and the height is 5. So 2 times 2 is 4, 4 times 5 is 20, so 20, and then you have to do 60 times 20, and you get to do 60 minus 20, 60 minus 20 equals 40 feet squared.
Problem asks to find the volume of the solid shown below. Do you see the triangular prism with the rectangular prism removed from its core? So you find out how much the rectangular prism is and how much the triangular prism is, and subtract the rectangular from the triangular prism. So in order to find out the answer, we have to find out base. We have to find out base times height of the triangular prism, and base times height of the rectangular prism. So in order to find out the triangle, you have to do 4, since that's the height of it, times 5, and then times 6. So 4 times 5 is 20, and 20 times 6 is... You could do it either ways. You could do 4 times 5, 6 times 5, doesn't really matter. But for this case, it's easier to do 6 times 4, and that's 12. No, 6 times 4 equals 24, and 24 times 5 equals... So 24 times 5 equals 10, 12, 120. And that's the base times height, and then you have to divide it by 2 since it's a triangle, so it equals 60. And in order to find this, it's 5 times 5 times 5. No, that doesn't make sense. It's 2 times 2 times 5. So 2 times 2 is 4, 4 times 5 is 20. So then you subtract 20 from 60, and the answer is 40.
Okay, this is our first of a few challenging questions. What makes it a little more challenging is that this three-dimensional prism has a piece removed from it. So the plan here is that we're going to find the overall object, which in this case is a triangular prism, and then we're going to subtract the rectangular prism inside of it. Okay, so let's start with the triangular prism. We have to follow our formula of area of base times the height. The base, or I should say the face of this triangular prism, is outlined right there. It's got a bottom of 6 and a height of 4, and don't forget it's a triangle, so when we go to find the area of that we have to take a half. So 6 times 4 is 24, half of that would be 12, and the height of the entire object, in this case is the length of the object, is 5, and 12 times 5 is 60, and that is the triangular prism. I'll label that tri for triangular prism. Now let's find the rectangular prism that is cut out inside right here. The inside measurement is a square face of 2. So once again we'll do area of base times height. The base of that square would be 2 by 2, and the overall height is the same as that of the triangular prism, which is 5. So 2 by 2 is 4 times 5 is 20. Now all that's left, and we'll label that rectangular base prism, all that's left is to subtract the 60 for the triangle minus the 20 for the rectangle, which gives us an overall volume left of 40, and that would be cubic feet.
Yes, Mr. M, I got this one right too.
I got this answer correct.
Mr. M, I got it right. This is a circle. So you have to find the circle, the area of this, to find the volume of this. And this is a pipe too, since you have to remove this part in the middle. Okay? So the radius of the big circle is 2, base times height, pi r squared for the circle. So that makes it pi times 4 times the height, which is 3. 4 times 3 is 12. That's approximately 12 pi. Okay, then to find the small circle, this is 1 pi, this is easy. Pi r squared is pi times 1 squared, which is 1 pi, or 3.14. So now you have to subtract these two. Wait, I forgot. You have to multiply it times the height to find the pipe, times 3, which equals 3 pi. And now you have to subtract it from this since it's a pipe. 12 minus 3 equals 9 pi. And that's approximately, if you want a decimal approximation, 9 times 3.14, 28.6. That's meters cubed.
This problem is complex and harder because it has two shapes, and you have to find the volume of both, and then you have to either add, subtract, divide, or multiply it. So with this problem, we're going to start off with the big cylinder, and you're going to do base times the height, base times height, and pi r squared. Two squared times pi times 3, because 2 is the base, and you have to do that squared, and then you should square that, and then the height is 3. So next you want to do 4 times pi times 3, and 4 times 3 is 12, so you're gonna get 12 pi. Now you have to find out the volume for the small cylinder, the little cylinder. So you're gonna start with base times the height, and then do pi r squared. So for this, radius is 1, and you want to square that, and then multiply 1 squared by pi, and then once you have to do that, you want to do 1 squared, which is 1 pi, and then multiply that by 3. The next problem you have to do what is 1 times 3, so 1 times 3 is 3, and you get 3 pi. And then once you find the volume for both, you have to subtract them, so I'm doing 12 pi minus 3 pi and you'll get 9 pi and that's about, get rid of my answer all the way up here, 28.26 meters squared.
Find the volume of the concrete used to make this pipe. Volume of concrete equals volume of big cylinder equals volume of small cylinder hole. The area of the small cylinder inside is radius times itself, which is 1, times the height, which is 3, so it's 3 pi. And the big cylinder is 2 times 2 is 4, 4 times 3 is 12, 12 pi. And you have to subtract these two, which is 9 pi, which is the answer of this.
For this problem, it's the same as the last one, but it asks, find the volume of the concrete used to make this pipe. Volume of concrete, volume of big cylinder, volume of small cylinder hole. So we have to find out how much the big cylinder is, and then we have to find out how much the small is and subtract them. So it says here that the radius is 2, so 2 times 2, since it's base times height. And in order to find out the base, it's radius squared times pi, and radius squared, the radius is 2, so 2 times 2 equals 4, and we're just going to keep it in terms of pi to make it easier. And then we do times height, and the height here is listed as 3, so it would be 4 times 3 equals 12 pi. In order to find the volume of the other inside circle, it's 1 squared times pi. So 1 squared equals 1 pi. And then it's the same height, so it will be 1 times 3 equals 3 pi. So you do 3 minus 12 equals 9 pi. And that's your answer.
Okay, I'm glad to see we had a few people attempt this more challenging cylinder question. Once again, it's a situation where a piece is missing. We have a cylindrical pipe, so we have an outer cylinder, an inner cylinder that's been removed or drilled out or molded out of concrete, however you want to look at it. So the step is going to be, first, to calculate the overall volume of the large cylinder using, once again, area of base times height. The overall radius is going to be 2 for the larger cylinder. So we have to figure 2 squared times pi, and then a height of 3. So 2 squared is 4 times pi times 3, which is going to give us 12 pi. We'll leave it in terms of pi right now, because now we're going to do the smaller cylinder inside, which has a radius of 1. So that's going to be 1 squared times pi times 3. So 1 squared is 1, times 3 is 3. We're looking at 3 pi. Final step would be to take the 12 pi, subtract the 3 pi, which gives us an overall volume left of 9 pi. And that is, once again, cubic meters.
I got this one too right, Mr. M.
I got this answer correct, but then again what I did was I rounded it, so like I'd say I got it correct.
Theorem, I got it right.
This this problem has two parts, so there is a big cylinder and a little cylinder, so we're going to start with the big cylinder. And the other side's going to be small. Okay. For the big cylinder, you're going to do base times height, and then squared radius, pi radius squared, and then you want to multiply that by the height. So radius is 7, and square that, and then times that by pi, and then times that by the height, which is 5. So 7 times 7 squared is 49, and then multiply that by pi, and then multiply that by 5. So 49 times 5 is 245. I believe it's 245. And you want to do pi. There you go. For the small cylinder, you will, not cylinder, for the small shape, you want to do, I said cylinder, I don't know why. For the small shape, you have to do base times height as well. Base times height, and pi, or squared times the height. And once you do that, so you want to find the radius, and the radius is 5, and you want to square that, and then multiply that by pi, and multiply this by the height, which is 3. Whoa. Which is 3. There you go. That was bad. 3. Okay. 5 times 3 is 15, and then 5 times 5 is 25, So, well, because 5 squared is basically written as 5 times 5. So 5 squared is 25. And then you want to multiply that by 3. And then multiply that by pi. And then you will get, when you multiply all these together, you'll get 75 pi. And then you want to add the two volumes together. So you're gonna add 245 pi plus the 75 pi, and you'll get about let me write these over here. You'll get about 320 pi.
Using volume in real-life construction, concrete weighs 145 pounds per cubic foot. To find the weight of the concrete
120 pi. And
it has two holes.
When you do this together, multiply the 320 times pi, you'll get about 1,004 point 8 millimeters, and that's gonna be squared.
So this one, you have to add on something, but still base times height, it's still a circle. So base times height, you have to find half of 14, which is 7, half of 10 is 5. We'll find the big one first. So 7 circumference pi times 7 squared, which is 49 pi. 49 pi. 49 pi times 5 is 245 pi. Then to find the small one, you have 5 times pi. 5 squared is 25, so that's 25 pi. Times 3. 25 pi times 3 is 75 pi. 75. Then you have to add that on. 245 times plus 75 equals 11, 12, 320 millimeters. No, 320 pi, and a decimal approximation. This is just about 4,938.24 millimeters cubed.
So in order to find the volume of both, you have to find the volume of that one and the volume of that one, and then you have to add them together. So here, in order to find the volume, you have to do base times height, and the base would be radius squared times pi. And here it shows the diameter as 10, so half of 10 is 5 to find the radius. So 5 times itself is 25 pi. And the height is 3, so we do 25 times 3, and that's 75 pi. And in order to find the next one, we would do the same thing. Here's 14, so half of 14 is 7. So it would be 7 times itself equals 49. And then 49 pi. 49 times 5, I'm going to do it over here. 49 times 5 equals 245. So we would now add 245 plus 75, and that equals 270. So the answer would be 270 pi.
Okay, we've had a few people attempt this more challenging cylindrical question. Cylinder stacked on top of another. So instead of subtracting like we did in the previous problem, we're going to be adding the two cylinders. So we'll get the volume of the smaller cylinder up above. It has a radius of 5. I know this because the diameter is 10. So we'll do 5 squared times pi times a height of 3. 5 squared is 25 times 3 times pi. We can rearrange the numbers because of commutative property. 25 times 3, we're looking at 75 pi for a volume of the smaller cylinder on top. Now let's do the same thing for our base cylinder here. We have a radius of 7. So 7 squared times pi times a height of 5. 7 squared gives us 49 times 5 times pi. 49 times 5 gets us 245 pi. Now all that's left is to add our two volumes, our separate volumes together. So we're going to do 245 plus 75, and that gives us an overall volume of 320, and once again we can leave that in terms of pi, and that would be millimeters cubed.
I did not get this one right, Mr. M. Thank you for showing me the right way, and I know my mistake.
Yes, Mr. M, I got this answer right and correct.
Yes, Mr. M, I got it right. Smiley face.
This problem is complex because it also has two parts. So you're going to start off with doing the rectangular prism and then the cylinder. So you're going to start off by the rectangular prism. And then you're going to do the cylinder. Cylinder, yes. The next step will be to we're going to do the rectangular prism first, and the first step you have to do is write the method, which is the base times the height, and the base is 16, and you want to do that by 16 again, because on both sides, and then you're going to want to multiply that by the height, the height, which is 24. And then that equals to 6,144 centimeters squared. 144 centimeters squared. And then now you want to do the triangular prism, and you're going to do base times the height as before we did with the rectangular prism, because that's how first you have to do, that's the method. And then pi r squared. Pi r squared. And then the radius is 4. The r equals radius, so the radius is 4. You want to square that because the little square there. And then 4 squared is 4 squared times pi, and then you have to times that by 24, and then 4 squared is 16 because like it's an easy way already. 4 times 4, and it's the same thing. 4 times 4 and then 4 squared is 16. So 16 times pi times 24, and then that equals 384 pi, and yeah. So then once you get these two volumes for both of the rectangular prism and the cylinder, you want to subtract them. So you're doing 6,144. And then you're going to subtract that by 384 pi centimeters squared. And then that's a 3, by the way. I'm sorry for that bad 3. Once you do this, you have to do 6,144 minus 1,205 and 0.16, and that's about, I'm gonna write my answer up here because I have my space down there. So that equals to about 4,938.24 centimeters squared. Centimeters squared.
Okay. This is a circle. It's a cylinder, and this is a square cube. So 16 times its base times height. 16 times 16 times 24. Since that's no, it's not a cube. It's a rectangular prism because this and this are the same. So 16 times 16 times 24 is 6,144 centimeters cubed. Now we have to find the circle. The radius is 4, so pi r squared. Pi times 4 squared is 16. Pi 16. Since this is already in centimeters cubed, you have to find the 16 pi, which is 16 times 3.14 is 1205 point 76. Okay, then you have to subtract that. 6,144 minus 1205.76 equals 4,938.24, and that's centimeters cubed.
So here it shows that there is a missing circle in the rectangle. In order to find it out, we're going to just find out how much the rectangle is, and then the cylinder, and then subtract. So in order to find this out, it shows that it shows how it's a square here, so as the lines, so it's 16 times 16 equals 16 times 16 times 24, and 16 times 16 by 24 equals 6,144. And then you have to find out this, and it shows the radius is 4. So in order to find the base, it's radius squared times pi. So it would be 4 times 4 equals 16 pi. The length is 24, so it would be 16 times 24, which is 384, plus 6,144, and that equals 6,528. So that would be the final answer. That's 2.
All right, here we have a situation of a square-bottomed rectangular prism with a cylinder drilled out of it, and we need to figure out the remaining volume. So again, we're looking at a subtraction situation here. We'll find the overall rectangular prism by getting the area of its base times its height. So the square has a side length of 16. So we'll do 16 squared for the area of its face here. And then the overall height is the length of the rectangular prism, which is 24. So 16 squared gets us 256. And then we're going to multiply that by our overall length of 24, which gives us a volume of 6,144, and that is cubic centimeters. Now we have to look at the cylinder that's been drilled out of the middle here. So we're going to apply our cylinder, once again, area of base times height. So pi r squared, they told us the radius is 4. So 4 squared times pi times an overall length of 24. 4 squared is 16. So we'll call up our calculator once again. 16 times 24 gets us 384, and that's also in terms of pi. Now this is the first situation we've had where we have a number that's not in terms of pi alongside a number that is in terms of pi, and we need to subtract the two. So this is one of those cases where we would definitely need to use our decimal approximation of pi here. So I'll take that 384, times it by 3.14 as our decimal approximation, giving us approximately 1,205 for a volume of the cylinder that's been drilled out. So now all I need to do is take my 6,144 and subtract the 1,205. And this is again an approximated answer, so keep that in mind. Calling up the calculator one last time, 6,144 minus 1,205. We're looking at 4,939, and that would be cubic centimeters.
Yes, Mr. M, I got this one right.
I did not get this answer right or correct, but I understand how to do it now, so I'll try my best next time.
I got about the right answer. I put 4,900. Oh my gosh. Okay, I put 4,938.24, and when you said it was 4,939. I got about just one number short.
Alright guys, so for this one, now you actually have to find out like the small area piece, Sorry for the bad drawing. Anyways, you want to find out for the big block and the cavity. The cavity is a piece, two pieces missing. So you want to start off with base times height, and then 1 times 31 times 0.66. And then once you multiply these together, you'll get 0.57 feet squared. Yes, 0.57 feet squared. And then now you have to find the cavity. So the cavity is going to be base times height. So base times height, and then you want to do 0.33 times 0.39.
Why aren't you talking? You're supposed to be talking.
I am. 0.39 times 0.66, and that equals to 0.09 times 2, and then that equals 0. We have 0.18 feet squared. And then when you get these two volumes, or once you get the volume of the big block and the cavity, then what you want to do is you have to subtract it. So you're gonna want to do 0.57 feet squared. Whoa. Feet squared minus 0.18 feet squared. 0.18 feet squared, and then that equals 0.39, and then 0.39, and then you want to multiply that by 145, and then 100 that and then once you get that, you want to that equals to about 56.55, 56.55, and you're gonna want to write this in pounds. So that equals 56.55 pounds.
Two holes here. This is a concrete block, so 2 holes. So we have to add these two and find the entire thing. So 1.31 times 0.66 times that. This is base times height would equal, and you have to find the weight. You can find the volume, but you have to find the volume to find the weight. So that equals 0.57 feet cubed. So you have to find the squares. 0.33 times 0.39 would equal, and you have to multiply 0.66 because of the height. Okay, that would equal point equals 0.08, let's just say 0.08. Okay, and you have to multiply that times 2 since there are 2 of them. Wait, no, that's 0.9 times 2, that equals 0.18. Then you have to subtract it. Okay, that would equal 0.57 minus 0.18 would equal 0.39 feet cubed, but it's not asking for the volume, it's asking for the weight. So that would make you define how much it is. So it weighs 145 pounds, 145. So yeah, so 0.39 times 145 equals 56.55 pounds.
So this question asks how using volumes in real life. Construction. Concrete weighs 145 pounds per cubic foot. To find the weight of the concrete block shown, you need to find its volume. So we're going to find the volume of the overall cube, and then we're going to subtract these individual cubes. So in order to find the full thing, you would do base times height, and this is the base, and this is the height. So we would do 1.31 times 0.66 times 0.66 again. So 1.31 times 0.66 times 0.66 again is 0.57. So that's how much volume is in the whole thing. But now we have to subtract these. So we're going to do base times height again. And it's the same thing here. It's 0.33 times 0.39 times 0.66. And that equals 0.09. And since there's 2 of them, we add 2 0.09s to get 0.18. And then we subtract 0.18 from 0.55 to get 57 minus 18. We do 8 minus 7, so we borrow. Equals 39. And then it says weighs 145, so we have to divide this, and it equals 56.55 pounds.
Well, here we are at the final problem, and in my opinion, the most challenging problem because it has the most steps involved. So congratulations if you made it this far. Even if you didn't get the right answer, as long as you came up with a plan, I tip my hat to you, because sometimes just planning it is the challenge. In this case, we have a concrete block, and they're asking us to find the weight of the block. But before we do that, we need to find its volume. Now, we've done similar problems like this before, so let's apply what we know. We need to find the overall block first. So we'll get the area of its base, 1.31 by 0.66 by 0.66. So I'll bring up the calculator to let us go through the decimals easily. We have 1.31 times 0.66 times 0.66, and that gives us a volume of about 0.57 for the overall block. Now let's figure out what one of these cavities has for its volume. Now the advantage here is both cavities are identical, so we really only need to find one and then double our answer. So let's figure out what one of these cavities has for a volume. Area of base would be 0.33 by 0.39 by 0.66. And once again, I'll call up the calculator to assist here. 0.33 by 0.39 by 0.66 gives us a volume of about 0.08. Now remember, there were 2 of these cavities, so I'm going to need to double that answer. So 0.08 times 2 gives us 0.16 for the volume of both of those cavities. Now we need to subtract the 2 cavities. So that's 0.57 minus 0.16. So 0.57 minus 0.16 gives us a leftover volume of 0.41. Now, they did say that concrete weighs 145 pounds per cubic foot. So the last step would be to multiply our answer by 145. So we'll pull out the calculator one more time, multiply the 0.41 times 145, and that gives us about 59.45, and that's pounds for the weight of this block in concrete.
Yes, Mr. M, I got this one right.
This problem was a bit hard for me, and so I really didn't get it right. So I'll try my best next time again, and maybe I can get it right then.
I got about the right answer again. You said it was 54.49 and I got 56 point something. Yeah.
Hello, boys and girls. Like I see so far, you're all doing a great job. I made comments on all the questions that you've done. I showed you the correct way to do them. And I also put together a couple of follow-up questions I'd like you to take a look at. One of them involves an error correction, and the other is a comparison question. Please take a look at these and comment.
This question asks to correct the error. So here it shows how its volume is base times height, and then it shows volume 10 times 5 times 7, and that equals 350 cubic centimeters. So we're going to make sure, so 10 times 5 equals, well we're going to do 7 times 5 equals 35, and then you add the 0 because multiplied by 10, that's the shortcut. And since it's a triangle, we have to divide it by 2, and that's his error. So 350 divided by 2 equals 175. So the error was that you have to divide by 2, and he did not do that.
The error in this problem is that the person did not divide by 3 since it comes to a point. So to find the answer, we must do 350 divided by 3, which equals 116.67 cubic centimeters.
So we have to correct the error because there's something wrong with this problem. So what we have to do, we're going to start off by writing the method, which is 1/3, which is 1/3 base times height, and right over here it says that it's only base times height, but this is not right. So you have to add 1/3 in between it. So then you're gonna want to do 1/3 10 5 times 7, and then once you multiply 10 times 5 times 7, you get 350. But that's what the answer says right over here, but that's not the answer because you still have that 1/3. So you would want to divide that. So 350 divided by 1/3, and you will get your answer as 175 centimeters squared. There you go. 175 again. 175 centimeters squared.
This question asks to correct the error, and the error is that they forgot to divide by 3, so it would be volume is base times height. The base is 5 times, it's 5 times 7, and the height is 10. 5 times 7 is 35, times 10 is 350, and divided by 3 would be 116.67 centimeters cubed.
To find out where they went wrong, you have to find the volume first to compare. So to find the volume, you have to do base times height. The base, to find the base, you'd have to do 5 times 10. And the height is 7, so just multiply all these, and you get 350. But you have to then divide it by 2, and that gives you 175 centimeters cubed. Where they went wrong was that they didn't divide it by 2 here. So the answer is 175 centimeters cubed.
You have to find the error in this one. So they did base times height, which was 10 times 5 times 7. 5 times 7 is 35, and then you add on the 0 since you're multiplying by 10, which is 350, and they left it at that. But it's wrong because since this is a triangle, you have to divide it by 2. So 1/2 of 350 is 100 something. 2 divided by 350 equals 170. 175, and that's cm cubic centimeters cubed.
So for this one, it asks, Michael says the volume locker has more volume. Jordan says the gym locker holds more. Who is correct? Prove it. So in order to find out this one, we need to find out the total volume of both of them. So in order to do that, we multiply 12 times 10 times 60. So we can do this mentally. 6 times 12 equals 72, and you add the 0. And then you add a 0 because it's 10, so 10 times 720 equals 7,200. And here, for the gym locker, we can't do it mentally, but you could do it on a calculator. So 12 times 15 times 48 is 8,600. It's a lot more than that. It's 8,640. So 8,640 is greater than 7,200, and that would be the answer. So to find who is correct, we need to see what the volume is of each figure. So to find this, we need to do length times width, which is base, times height.
and that equals 7,200. And for the gym locker, the same, so we multiply them all, which equals 8,640, which means Jordan is correct.
This problem was a bit hard for me, but I got it. So so first I thought in my head who is correct, and I'm like, what the question is, who is correct? And then I started off by doing the school locker, and I ended up getting the answer of 7,200. And then once I got the volume for that, I did the gym locker and got an answer of 8,640. So I said that the correct one was Jordan, because he got 8,640.
This question asks for which locker contains more, and Michael says that the school locker can hold more than the gym locker, and Jordan says the gym locker can hold more than the school locker. To solve for this, you have to do 12 times 15 times 48, which would be 8,640 inches cubed. And to solve for the school locker, you did 12 times 10 times 60, which would be 72,000 inches cubed, and which means Jordan is correct.
To find which locker has more volume, you have to find the volume of each one. To find the volume of them, you have to do base times height. The first one is 12 times 10 times 60, and you get 7,200. And for the second one, you have to do 12 times 15 times 48, and you get 8,640. So the gym locker is bigger because 8,640 is greater than 7,200. So the gym locker is bigger, and Jordan was correct.
This one you have to find out who is correct, Michael or Jordan, because each has a different preference. Michael says the school locker holds more, and Jordan says the gym locker holds more. So to find out who's correct, you have to find the volume of both of these. So to find out, you have to multiply these all. So the SL, the school locker, is base times height, which is 12 times 10 times 60. 12 times 10 is 120, so 120 times 60 equals 7,200. And then for the gym locker, 48, it's the same thing, base times height, 48 times 15 times 12. So, okay, 48 times 15 times 12 equals 8,640. That means Jordan was right, because this is larger than this, so the gym locker holds more.